Hello everyone, this is Rupesh and I'm watching CPB Nerds video series on data structure, and this topic is XOR linked list. Have you ever heard about this XOR linked list? It's not a new thing. It is really very old way of making a singly linked list work like a double linked list. You know the problem with the double linked list, right? I mean, if you have double linked list, you have to store this address and this address. I mean your previous address and the next address, and this goes here you go the data. Okay, so your previous and next. And in doubly linked list, in single linked list, your node look like this. Here goes your data and this is your next. There is no previous in single linked list. Okay, so this is single and this is double. So what is the loss in double? I mean, there is a positive side to this double. You can come back in your linked list, right? So double have two-way communication like this, and single have only one-way communication like this. So if you are standing at this position, then you don't know this one and this one and this one. Or maybe if you are storing, then it is obvious that you are wasting some of the memory. Okay, so in single linked list, it is clear that you are standing here, you don't know about this one. But in considering, yeah, obviously this is your head. So in double linked list, if you are at this place, so you can go here and here, both the places, because you have next and previous. So we all know this. Now the question is, how would you make this single linked list act as a double linked list? And that's where this XOR linked list comes. And not only XOR, there is something called addition linked list. There is another thing called subtraction linked list. So they all do the same thing, and they all have different way of achieving it. Okay, so in this video we'll concentrate on XOR linked list. You will understand the concept of addition and subtraction linked list very easy if you will understand this. Okay, we are good now. Okay, this is first, this is second, and this is third. Fine, the node says this is singly linked list but act like a doubly linked list. That's what we'll see in a moment how it will do that. So let me go through these points first. We can go forward and reverse in XOR linked list because it serves as doubly linked list, and it is memory efficient doubly linked list. Yeah, people call it memory efficient doubly linked list. So this is another name of this kind of singly linked list. You actually happen to save your one place. So if you are using XOR, it will be memory efficient, but you may have to do a little bit of calculation that we'll talk a little later. And the third point is, instead of storing address of next node, it stores XOR of previous and next address. This is really very important. If you remember this, it is done. I mean, you know all the things. Okay, so in single linked list, things are like this, right? I mean, you have one data portion, so this is your data here, and this is your next here, right? We all know that this is your address. Let's come to the XOR linked list. So as I said, the first node, and yeah, this is your data, and this is your XOR of previous and next. So for simplicity, we'll call it N, P, and X. So this is a traditional name for this place actually. So this is NPX. N means next, P means previous, X means XOR. So you will have next address, previous address XORed, and you will put that value here. So as you can see that the next of this one is 200. Okay, I mean the address of this is 200. So 200 XOR 0 because there is nothing before this. So 0 XOR 200 will go here. It means actually it will be some 200 only, because if you do XOR with 0, you will be exactly getting the same value. So this will contain 200. Now come to this place. As this is having actual previous and actual next, what this is going to have? Yes, 100, which is address of this node, and XOR, and then address of this one. Okay, and this value might be something, I don't know what it is, but it is going to be something, and that something we will store here. Okay, I mean the result of this will be stored here. And similarly, if you come here, you don't have next to this, but you have previous, right? So your previous node's address XOR 0, and that value will go here. So ultimately you will store 200 here. So this is how you prepare your data in XOR linked list. And can you see that you still maintain this format where you have data and your link to next node, correct? So now let's look at the traversal point. Oh, let me just revert this. So this was about preparation. Now let's see the traversing. So from here you want to go here, right? And as I said, it can go bi-directional. So we will see that bi-directional stuff. Let's go forward first. So as I tell you, if this is your current CURR, then the formula becomes like this. You have address of previous, excuse me for my writing, and this is your one part, XOR operation, and your currents NPX. So this is going to be your currents NP and X. If you will do this, this will give you next. So let's do that here. What is this? This is your first element, first node. So you have this as a current. So currents NPX would be, let's write that here, 200. Let's make it 200. And the previous, address of previous is nothing because you don't have any previous node to this. So what you will have 0. So XOR between 0 and 200 would be 200. So can you see this? You have the address of your next node. I know it will look magical, but this is how it is. Okay, so we came here. Now let's make this one as current. So what will happen? Whatever is the value here, I don't know what is 100 XOR 300, but don't worry if you don't know this, don't worry. Let's go with the formula only. So our previous node, so this becomes previous now, okay? So this is your previous, okay? So previous node's address is 100. Let's write that. And this XOR operation, so this is your XOR operation. And this, because currents NPX, so 100 and XOR 300. So what is the result of this? This is 300 because XOR and XOR will cancel out this one and this one, because XOR says that if 1 and 1, it will become 0. If 0 and 0, it will become 0. You should not have the equal digits at both the side, right? So if it is there, it will be 0. Otherwise, it will be 1. If it is 0, 1, it is 1. If it is 1, 0, it is 1. Okay, so considering that this and this are equal, so their bits operation will be equal and they will result as nullified and or maybe 0. So if the result of these two XOR is 0, then 0 XOR 300 is nothing but a 300, right? So can you see this? You were standing at this location and you wanted next. So you got next. See, this is 300 and your address is also 300. So this looks pretty easy now, right? Yeah, actually it is easy. So we saw how to move forward. This is the only way. This is the formula. Address of previous XOR current NPX. So you have this current NPX right now and the previous address, just do this, you will get next. Because your NPX somehow storing your next elements data with some XOR operation with your previous data. So if you will do the XOR with the same data, it will get nullified, right? And magically you will get your own, the next one. So this is how it is. So it's not a very big thing. And similarly, you can use addition here. Instead of this XOR operation, you can use addition and subtraction and you will get the same behavior. They are little bit different, but not that different at all. The concept is same, okay? So we were looking at forward case. Now let's look at the backward case. So let's suppose you was standing at this location and you had this 200. Obviously, you had this 200 NPX. Now, as we are going backward, so formula will change. Before we were looking for next, this time we'll look for previous. So the previous formula is address of next XOR with similarly current NPX. Okay, and this is your NPX. I told you this is not a next location, this is your NPX location. So now the formula is like this. So if you are standing at this location and you have 200 as your current NPX, Let me remove all these. So you will have address of next. So address of next is nothing here. So you will have 0 and this one, which is nothing but XOR operation, and current NPX. Current NPX is 200. So let's do that and see, you got 200 because 0 XOR 200 is 200. So you got the previous one's address. So see, this is your 200. Similarly, if you are standing here, then the previous one's next one's address, this is 300. So let me write 300, and your current NPX is this one, 100 XOR 300. So XOR, which is this one, and then 100 XOR 300. So this 300 and 300 will go. You will be left with 100, which is nothing but this one. So you know you were standing here and now you can go here. So this is how you will traverse backward. So this becomes your forward formula and this becomes your backward formula. So yeah, it's fun, right? So if you like this, don't wait, just pause this video, go and like, and then come back, okay? Because I know you may forget and maybe your girlfriend or mom will call you. And I suppose you are done, so let's move to the next. Yeah, so we have covered this one, this one, this one. Okay, let's talk about the pros here. So the pros are, it takes less memory than doubly linked list, but act like doubly linked list. Obviously, we saw that because doubly linked list will have one extra pointer. We don't have extra pointer in doubly linked, this XOR linked list, correct? Now, let's talk about the cons. Okay, do you think really we should go about it? I think we should because they are very important. First one is debugging becomes hard. Actually, it is the biggest one. Why? Because we don't store actual address. So that is one big point. Another one is code complexity. Can you see this? We have this formula, and if I'll show you the code, that is also a little tedious because we have to convert these addresses into some integer format. Until unless you convert this address, because this is an address type, right? So you have to convert that address into some long integer so that you can perform this XOR operation. Until unless you convert them, you cannot do this. So this conversion is also required, and maybe some compiler don't allow this conversion also, right? So that is also one of the problem. So the code complexity will increase, and garbage collection is difficult because no proper address is stored. Correct. So if you learn something new, I know you might have learned something new today. So at least a like button. Yes, just hit that like button and subscribe to my channel if you are new to this channel. You will get the notification for upcoming videos like this. I'll see you in the next videos, guys. Bye bye. Tata.